In this video we're going to talk about heat and specific heat capacity of objects. And when we talk about heat and understanding how much heat is absorbed or given off, there's an equation that we use, and it looks like this. And that equation is Q equals heat, M is mass, C is the specific heat capacity of whatever substance you're dealing with, and this triangle T is, or called delta T, is the temperature change. And with this, just like any other equation that you use, given all the variables except for one, you should be able to find the one that you don't have. And first we're going to talk about an example. So if we have 341 grams of water, and it changes temperature. It goes from 20 degrees Celsius to 85 degrees Celsius. That gives us a temperature change of 65 degrees Celsius. So with this information, knowing that we're dealing with water, and we know that the specific heat capacity is 4.184, and the units here are joules over grams degrees Celsius. So with that information, we'll be able to calculate the heat that was absorbed by the water with our equation. So Q is equal to 341 grams times by this 4.184 specific heat capacity, joules over grams degree Celsius, and then multiply that by the 65 degrees that the water increased. And once we do that, the result comes out to be 92738.36 joules, because these units will cancel through the process, and so we end up with joules, which is the units of heat. So with that example in mind, we can now calculate any of these four values if we have three of the others. For example, if we want to find the specific heat capacity of a certain substance, say we don't know what it is, and based on the specific heat capacity that we get, we'll be able to determine what the substance is. So if there are 4,400.2 joules absorbed with a temperature change of 35 degrees Celsius, and it has a mass of 280 grams, we should be able to arrange this equation so that we can end up with specific heat capacity. And we do that by dividing this side by the mass and by delta T. Those will cancel. And we divide this side the same way by the mass and delta T. So our new equation will set C equal to the heat absorbed, 4,400.2 joules divided by the grams 280 grams times by the change in temperature, 35 degrees Celsius. So once we do that, we end up with 0.449, and that'll be joules over grams degrees Celsius. And that's our specific heat capacity for the substance. And given a list of different heat capacities, you'd see that that is the heat capacity of iron. So this equation is helpful not only for finding the heat absorbed or given off during a reaction, but it also helps us to find mass and the change in temperature or the specific heat capacity of a substance.